Well, hello everyone, and welcome back to Adrian's Digital Basement. You know, I was thinking last night that there's something I haven't done on the channel in seemingly forever, and it's work on any Commodore 64s. I went into my stash of broken stuff, and I think all of these 64s you see on the bench here are broken. Don't worry, this is not going to be a repairathon, and I don't know how many of these we're going to get through on today's video, because obviously my videos are unscripted and I don't really know what's wrong with these. So it might be really quick and easy fixes, or maybe more in-depth troubleshooting will be required. So let's just grab the first one of these off the pile, bring it over to the bench, and start troubleshooting. So all of these machines have previously been tested. That's what these post-it notes are on here. And it would have been on test and try episodes on the second channel, where I sort of went through and, well, just tried to figure out just some rudimentary troubleshooting. It's really mainly just to see if these machines are already fully functional or not. Because if they do fully work, then they're just not going to go into the pile of machines, which sits over there. That basically is stuff that I need to repair, like all of these machines. So this machine right here, it says, powers up to basic, corrupt screen. So that would have been what I figured out on my test and try. So first thing we need to do is get the lid off this thing and take a look on the inside. Part of me is kind of worried that I'm actually going to be a little bit rusty at figuring out what's wrong with these machines. Certainly, I don't know, when you work on lots of other repairs, the stuff sort of fades from your memory a little bit. There's just so many different symptoms on different types of machines, but maybe it'll be like riding a bike and it will just come back to me. So this machine obviously is in really good physical condition. It doesn't seem to have a lot of yellowing. It's one of the made in the USA models. And if we pop this thing open, oh, the case has a good crack to it. There it is. This is one of the later motherboard revisions. Oh, well, that's interesting. It's just missing a character ROM. That would kind of explain why we have corrupt screen, because without a character ROM, you're not going to get any characters. This is kind of what I was talking about. Since these videos aren't scripted, I don't really know which of these are going to be interesting repairs and which are going to be boring repairs. If all this thing needs is a new character ROM, then this is going to be definitely in the boring repair camp. And we'll just put a new ROM in there and then we'll move on to the next machine. So if we turn this thing on here, let's just see the symptoms currently. Wow, we're just getting absolutely nothing. Now, the interesting thing is, if we take the dead test ROM and we stick this in, then we should have a working machine, actually, because the dead test ROM does not rely on these ROM chips here. So let's see if this thing works. I'm using the RetroTink 5X Pro. Okay, interesting. I can't remember off the top of my head if the dead test ROM does rely on the character ROM, but I thought it did not. So this machine actually may have some other faults. Yeah, do you see how there was that moving character and it's moving in multiple positions? That almost seems like we have some type of an addressing issue on this machine as well. All right, I have a spare motherboard right here. I'm just gonna steal some chips off here. What's really frustrating down here, and I guess it's because of my disorganization, I have misplaced my chip lifter, the WeHat chip lifter I always use. The other thing that went missing the other day is my little tiny dropper bottle of flux. I was using it and then I just can't find it. So my assumption is it rolled off the bench onto the floor and I can't, and it like went underneath something, and I'll have to get down and really search around. Okay, so character ROM off this motherboard. This motherboard does work, by the way. So I'll just stick this in here, see what we get. Okay, let's pop the cartridge out. Turn this on. So this whole black screen thing, you know, it's interesting. I'm noticing one thing about this motherboard is all socketed. Well, I mean, all the main chips. That's kind of cool. Okay, so we are also still getting nothing. Now, my note that I had before says powers up to basic and corrupt screen. So that's not happening right now. So obviously we have an intermittent fault or something else that's kind of gone wrong or gotten worse on this machine. Let's put the dead test back in. Oh, okay, so now we're getting flashing. I wonder if this is a PLA problem. I'm assuming that whoever worked on this machine last took the character ROM out, maybe because they thought that corruption that it was getting on screen was due to the bad character ROM, and then they just gave up on this machine. I guess the first thing we should do, let's take a look at all the chips on here just to make sure that everything is in the sockets correctly and also the right chip. So since everything is socketed, that means things could be moved around. So we have a revision 3 of the kernel. That's the character ROM I just installed, and that's the basic ROM, the 226. We have two 6526s, and looking over here, right here. So these MOS ICs are super incredibly unreliable. So it's the, oh, and there's one right there as well. So these chips just have a tendency to go bad. These are just normal 74LS logic, and MOS was making these because I guess they couldn't get enough of the regular 74LS from actual manufacturers like Motorola and National Semiconductors. So they spun their own, and they were absolute garbage, complete and utter garbage. Looking over here, the clock synthesizer is a 7701. I think 8801 is the other part number. I think they're interchangeable. And we have an R8 VIC2 chip. So take a look at these chips here, 7709, 7712, 7707. And if we take a look at this motherboard, which works, one of the potentially bad chips is this one, U14 and U27. If we go to here, when we look for U14, there it is. It's the 74LS258. I noticed this one also has one of these horrible 7707s in there as well. I think that's in the same exact position as this one. Yes, it is U8. So it's the same exact part number. Even though the chips have moved around a little bit, the silkscreen markings just tell you exactly which chip is which. So by looking at one of my other motherboards that has all the chips populated with regular 74LS parts, I made this little conversion chart. So the 7707 is an LS06, the 12 is an 08, and the 09 is a 258. Let's just quickly take a look at the schematics and take a look at what these chips do, so we can try to figure out which of these is the most likely culprit for the issue we're seeing, which is the black screen. And in the dead test, we were getting the addressing error where like the cursor was writing to multiple locations. My money, by the way, right off the bat, is going to be this one right here. All right, we're over on Zimmer's here. Let's try to figure out which is the right one to look at. So this is a 250-425. And if you search for 250-425, you get these right here. So it's a 251-469. Yeah, it's a little confusing. There's like two different numbers. And right away, I'm actually noticing that these are the multiplexers here, U13 and U25. And the parts we had wrong were U27, U14, and U8. So it was neither of those. So when these go bad, you get all sorts of weird addressing problems and RAM problems, and that's because those are converting between the normal address bus lines from the CPU over to the row and the column addresses that are used for the DRAM. But take a look at this. Here's U14, and this goes between the VIC2 chip here, these extra address lines, and oops, over here to the RAM. So this absolutely plays a part in any kind of graphical corruption you can get. When this chip goes bad, you're going to have all sorts of issues. The other two bad chips were U8 and U27, which U27 is right here, and it's just like a regular TTL logic gate type chip, and it's obviously used as different gates all around the machine. Not quite sure a bad one of those will create a situation where the whole system won't boot. Oh, there's U27 as well. So, okay, well, it's also the chip select line that goes to the color RAM. So if that were bad, you'd have all sorts of like color RAM issues. I don't necessarily think we're having that problem. Let's put the dead test in again. Let's see if we can get any kind of life out of the dead test, because anything we can see on screen is a visual clue that could help us. So we'll turn on the machine there with the dead test in. Oh no, okay, so now it's just flashing that there's a RAM problem. Now I don't think it's an actual RAM problem, and I'm touching the RAM chips. None of them are hot or anything like that. So if U14 is bad, I think the only symptoms you generally are gonna see are going to be graphical corruption and color RAM corruption. I'm not necessarily sure that it's going to corrupt the RAM itself, which is what we're seeing here because we're getting this flashing code for bad RAM. But take a look at this. So these are the multiplexers that drive the DRAM, and there's U8, and that's one of the MOS chips there. It's an LS06. It's an open collector driver, and this drives directly the output enable pins on these two multiplexers. So if that's bad, then we're also not going to necessarily have a working system. So we have a lot of potential issues here, and I think the next step is going to be to break out the oscilloscope, and we're going to start probing around on these various signals on these potentially bad chips here to see what we think is going on. All right, first signal we're looking at is pin 3 here on the 7406, so U8. And this is the output enable signal for the multiplexers. And well, it looks a bit low, but I guess that's okay. And here we're looking at the output pin, and that looks absolutely fine as well. So I don't think there's a problem here with the output enable on the DRAM. All right, I moved over here to U14 and I'm on pin 3. That doesn't look like a good signal right there. Just power cycle the computer. Nah, that looks terrible. Pin 2 is just 4.9 volts. Maybe that's normal, I don't know. Power cycle the computer. Could be stuck high as well. Okay, and now we're on pin 5 here, and that also just sticks it high. Oh, and take a look at that. We're getting a video signal. Wow, okay, that's a mess. That is a real mess. Definitely have some addressing problems. I'm going to say that this chip right here that I'm on, this MOS chip, this is a problematic chip right here. It's not burning hot, it's warm. Okay, actually, it's very hot. I just realized, yeah, okay. I think that chip is bad. So let's start with this one here. The outputs are looking weird on the oscilloscope, and we're getting all that kind of like corruption there on the video, which is just a pure indicator that we're having some kind of an issue with the addressing going to the VIC2. So let me swap that out. All right, there it is. The chip has been replaced, 258. I put a socket in there and swapped in this part I think is good. With the power plugged in, let's turn the machine on. Nope, we're still getting, oh, yes, that was it. That was it. So this MOS chip was true to its nature and totally sucks. I'm just gonna probe those same pins that I probed earlier that were looking all screwy. This is pin 2, and obviously it looks good. Pin 3 also has normal activity. I think this one was high all the time, or I don't know, just had something weird looking on it. And then here's pin 5, that's VA15 according to the schematic, and also, yep, normal activity. I mean, it's a bit low, 3.8 volts high. That's good enough for the Commodore 64, and it's good enough for regular TTL. And if I feel this chip right now, I know you can't see what I'm doing here, but if I switch this to that chip is cold to the touch. Let's see what else is warm here. So that's warm, that's the PLA, and the VIC2 is warm, but that's totally normal. SID feels okay. So let's do the full diagnostics on this thing now, just to see if everything is good. So we'll put in the regular diagnostic ROM. The diagnostic harness that viewer Mike sent in is all connected up to the machine. Let's power this on. Now, while this runs, I'll just talk a little bit about these MOS logic chips. So if you have one of these machines and you're not super good at troubleshooting and it's not working, well, you should probably just try to replace all these MOS 74LS logic chips. That's a really good first start, just to see if your machine is going to work. Obviously, if you have one of those oscilloscopes, even the really inexpensive one, start probing around on the inputs and outputs based on the schematics. And if you see stuff that just doesn't look right, well, then that kind of gives you an idea. Oh, by the way, look at this. This thing seems to be working perfectly. Yes, it's working great. Anyways, yeah, so it's kind of a safe bet if you just replace these, because they really are junk. But you know, we left 2 of them on the motherboard and they're fine. Seemingly everything here is working. It's usually the more complex ones that seem to be the problems. The multiplexers for the RAM, which I think are these 2 chips, and then these types of more complex chips, these ones are the ones that seem to break the most. The regular ones are just like and, or, gates, things like that. They generally seem to be a little bit more reliable. All right, so this machine does appear to be working flawlessly now, just with that one single chip. So I think everyone knows what time it is. Feels like it's been quite a while since we've done one of these. We'll grab the Easy Flash cartridge here. We'll connect that up. I'll have to grab a joystick here because I don't have the keyboard connected. Yeah, we're hooked up through composite, by the way, so that's why it looks not super good. Although, it's not bad. And this particular revision of the motherboard, the one that has like this clock generation circuit, seems to result in pretty good video output. The RF modulator on this one is different than the one on the older boards, the bread bins that is. And this one just generates really clear output, both S-video and composite. All right, 8-bit dance party, it's been forever. Let's turn the volume up. This is also a good test to make sure that the SID is actually working correctly and sounds so far perfect. All right, well, yeah, that is a fully functional SID. This machine, which is a really quite a nice 64, because it's got everything in sockets other than the RAM and stuff, but all the main ICs are socketed. And like I said, these later revisions, they just have really good, clear video quality. And yeah, it was just that one MOS chip. And it's funny, just when I visually inspected it, my eyes went right to the bad MOS chip. Well, not to the bad one, but to the MOS logic chips that were on here. And yeah, a little bit of troubleshooting later with the oscilloscope confirmed we saw the bad signal. and now it's working. And one other thing I'll have to add, it's not always the PLA that's gone bad on the machine, because this has the original MOS PLA, and yeah, it's working fine. At least for now it is. So this machine is now fixed 100%. We had bad U14 and we had a missing character generator. Sweet, really good condition as well. All right, let's move on to the next machine. So this one, let's see what we see. Black screen with a white line. So that indicates to me that, oh, by the way, this is the bad MOS chip. I put a little X on there. That indicates to me that we have a good VIC. Well, there's a VIC installed, and there's also an RF modulator that's working. So where you get NTSC video signal output of this machine with the white line on the left side. So that's what I was saying with that. Why don't we just open this thing up? Oh, look at that. Warranty void if removed. Wow, that's sort of weird. You don't normally see those on 64s, bread bins at least, here in North America. And when you look here at the case, it looks like someone went a little, like, they were a bit overzealous putting in motherboard screws. I guess at the factory, this machine definitely is a USA-made computer, and that is a Commodore sticker. So we're gonna have to break the seal on this thing. Well, actually, let's just double check to see what this does before we actually open that up. Let's make sure it's not just working, because that's kind of cool that it has that awesome sticker there. Kind of like that. So we'll turn that on. And there is the video output, and it's basically nothing. Now, currently, due to the way the RetroTink is set up here, it's not going to show us the white line. We have to kind of move this over. There it is. So there is the white line, and that means that we're getting a video signal out of this thing, and we're just getting a good old black screen. Why don't we, if I, oh, here, oh, that's cool. Something different. I was going to say, let's put in the dead test here. Let's see how that works. Because sometimes it can reveal what exactly is going on here. So we just have to wait a moment. It's checking the RAM. We'd see the flashing white screen if the dead test were detecting any kind of RAM issues. Now, RAM issues, by the way, the other one, oh, look at this. It is working. So what does this tell us here? We'll let it run through a little bit, but I find that if the dead test works, and say the 0 page, that's DRAM, the stack page is all DRAM. If the DRAM checks work, that means that we probably have a bad ROM chip in here. Maybe the basic ROM or the kernel ROM has failed, and everything else in this system seems to be working. And the reason why the dead test is different and maybe a good test for 64 when you have bad ROMs is because what happens is when this cartridge is installed, the dead test cartridge, it actually has a signal that goes to the PLA that disables the ROM chips. It just doesn't select them at all. It never turns them on. This basically replaces all, oh look, it does say we have bad RAM. So it's claiming that we have bad color RAM and bad DRAM. I'm gonna power cycle this thing. Let's see if we have the exact same results on the second pass. Oh, look, now it's flashing to tell us we have bad RAM. Well, this could all be PLA related here. PLA, obviously, very common failure on these bread bins. Power cycled it. Now it's not flashing that there's bad RAM. So let's see what it does. Anyhow, as I was saying, I forgot what I was saying. I kind of lost track. I was distracted, like squirrel, squirrel, by the error that showed up there. Anyhow, yeah, so dead test does tell the PLA to just disable those ROMs. They are completely out of play. That is one of the things that the 64 is able to do, is it's able to switch in and out ROMs. It's like the bank switch them, essentially. So there's an XROM signal here, which just means all the ROMs are external. I think that mode of operation comes originally from the Commodore Max, which was like the precursor to the 64, only released in Japan. I don't think this thing's even working at all now. Yeah, that was just a black screen that was giving us nothing. So we had one good diagnostic session there with a dead test, and now this thing has like degraded even worse. Anyhow, yeah, dead test disables the ROMs, so you can actually pull the ROMs out of the machine and dead test should still run properly. But if your PLA is failing, that's what does a lot of the chip selects on the 64, and a bad PLA, it's gonna do some weird things because the outputs, instead of being at 0 or 5 volts, they're gonna be like floating in the middle. And you can use your oscilloscope to actually take a look at those signals and just see if all the outputs on the PLA look correct or not. And if you see anything that looks out of the ordinary, it's gotta go. All right, well, the machine is clearly not working at all now. So that means we're gonna have to break the seal. This machine has clearly never been opened, or if it was open, maybe at like a service center, they applied that sticker after it was worked on at some point in the past. Ah, poked right through. How sad, right? Anyways, it's got to happen. We'd rather have a working 64 than one that is never been opened. Same revision of motherboard that we just worked on the previous one, but this one has the full original RF shielding on it. So the fact that that was missing from the last one just kind of indicates that, yeah, obviously we know someone had been in that other machine because it had a missing character ROM chip, right? It also had a missing screw. This one was missing on the motherboard, if I recall correctly. This thing is clean. I mean, well, the shield is clean. I guess that's not super clean. All right, so another motherboard where everything is in sockets. Excellent. But we also have another motherboard where we have the same junk right here. Oh no. So this may well be, oh, the multiplexers are also MOS ICs. No, no, no. Look how the RAM is like random. We have like Fujitsu. I think these are like Matsushita or Panasonic. And look at all this flux. Yeah, someone's worked on this. In fact, these look like original chips, and those are all replacements. So I have to imagine that warranty sticker we saw on the bottom was actually due to some service, maybe at a service center. Looking over here, we have an 8701, so this is the slightly later version. I think the date codes always seem to be 88 on these. This machine obviously is kind of late. You can see 88. And I don't know for sure. I mean, this thing has 84 chips in here. Yeah, lots of these are from 84. So feels like we've had some service on this machine here in this area as well. At least in 1988, someone was in here and maybe they were fixing this DRAM, like some kind of catastrophic failure that happened in here. But unfortunately, they didn't take out the junk right here. They didn't take out the trash. Maybe people didn't know at that point that that was the total trash. All right, I pulled this thing out of the case and I removed the RF shield, and I realized that I was wrong about which were the MOS chips on here. I actually created another little cheat sheet here to indicate which were actually the chips. So I was thinking that this one right here, this 258, was actually a MOS chip. It's not, it's a real chip. The MOS chips on this board are actually these two here, 7708s, and I wrote on my cheat sheet here, that's LS257, and then 7711 is an LS139, that's this IC right here. And then we have our old friend, the 7712, which is an LS08, that was just like on the other motherboard. And the other one had this chip here, the 7406, as a MOS part, but this is actually a Fairchild part. So what we need to do is just really focus on these MOS chips first, just to see if any of these look wrong and out of the ordinary. So first we should focus on these multiplexers, because these go bad a lot and the MOS versions are especially super duper unreliable. So everything on the left are inputs. These are address lines that come from the CPU. And then everything on the right here is the output of these chips, and it generates the row, well, the address lines that go to the DRAM. And that has to be multiplex because there's like rows and columns. That's the way the RAM is addressed, and that's with the CAS, the column address select line, and the RAS, row address select line. So what we're gonna do, and I have the dead test in there because I want that RAM test to run when I power it on, I'm just gonna go through all of these lines here. So we're gonna start on pin 4, and that looks normal. So that's plenty of activity, and that's exactly what we wanna see. We just don't wanna see stuff that's like stuck or sort of in the middle or doesn't look right. So that's 4, and this is 4 on the other one. Looks good as well. Here we are on pin 7 on one of them, and pin 7 on the other one. Looks good, both of those look good. Okay, here we are on pin 9. That's the top one. Bottom one, both looks good as well. Don't worry that they look slightly different, and that's okay. It's because the way that the VIC interacts with the RAM address lines and stuff, I think it just results in slightly different activity. And then 12. Okay, so that's on the bottom one, that looks good. And this is on the top one, and that looks good. So everything so far is looking okay for the signals coming out of these multiplexers. Now, I've had failures before where everything looked okay, like the signals you saw were fine, but it was almost like something was wrong internal to the chip with the truth table. So like what was coming in versus what's coming out was wrong. So it was generating good looking signals, but they were the wrong signals. Those are harder ones to troubleshoot because you would have to use a logic analyzer to look at the inputs versus the output and then compare that to a truth table, like in the data sheet for the 74LS257. So we're just going to imagine that the signals we're seeing here are the correct signals. All right, so the next thing that could be problematic is the LS139. And I'm actually not 100% sure where that chip is actually used on the system here. Oh, there it is right there. All right, well, let's take a look at the outputs of this. So what this is it's generating the select lines, I guess, for the VIC and the SID and color RAM, and also the CIA lines. Now, if this were bad and selecting multiple things at the same time, like you had multiple low outputs from this, because remember, select lines for logic chips, at least on this machine, are active low. So when the signal's at 5 volts or, you know, TTL high, the chip is not selected. But if, for instance, if output 4 and 5 were high all the time, that means the VIC and the SID would always be selected and they would be conflicting with each other. So I'm on pin 4 on the 139 and it's all high, which is fine. It's just because I think like right now the dead test cartridge is not even talking to the VIC chip or the SID chip. So we're on pin 5, same thing. It's 4.5 volts, that's totally good enough. And then we have color RAM, that's also high, so that's completely fine. And then pin 7 seems to be like a kind of a cascade that goes from this chip back to itself, because this is both U15, because there are 2 separate units here. So that looks fine as well. And this is pin 9, which is, I don't know, goes to something. It looks fine. 10 looks fine as well. And then the next 2 are CIA lines. That's 11 and 12. Okay, so at least that chip is not creating a bus conflict. I don't know if it's working correctly. So like if it weren't working correctly and it never went low, then maybe it would never turn on the VIC-2 chip. And then that means that we'd never see a picture. But the computer wouldn't be crashing. It would still probably be running. And if we ran the diagnostic ROM, we would like hear, well, we wouldn't hear anything because if it wasn't selecting the sound chip. But a bit of a tricky problem to troubleshoot. But what we can do is take out this dead test and let's take a look at the VIC line. So that's pin 4. And let's see if we see activity on here. Oh, we do. Okay. And pin 5, we're not going to see anything because the SID chip is not being, okay, well, no, it is doing something there. And pin 6, color RAM. Yeah, okay. So, I mean, that's what I mean. The outputs look okay on that chip. Nothing looks completely out of the ordinary. At this point, I think now that we've sort of ruled out those 2 complex chips, I think the next thing that I want to look at is the PLA. The PLA is just always highly suspect on these older bread bin machines. And the truth of the matter is that those MOS chips are also highly suspect, but we should never discount the PLA as being a problem either. So U17, it says PAL, so programmable array logic, as opposed to programmable logic array for PLA. Either way, that is the PLA itself. Now, as I mentioned, for the multiplexers, everything on the left side are inputs, everything on the right side are the outputs. So these are the signals we need to look for. The typical failure with these is that an output gets stuck low or sort of stuck at like 1 volt. So chips might think it's selected or not, and it's stuck all the time there. So for instance, if like the output of the basic ROM here, pin 17, were sort of at 0.5 volts or 1 volt all the time, then the basic ROM would think that it's always active and it would always be talking on the bus. So anytime an address line was set up, the basic ROM would be like, oh, putting its data on the bus, creating bus conflicts all over the place. So that's typically what happens when a PLA fails. So all you really need to do is use an oscilloscope and just look at the outputs, everything here. So 10, 11, 12, 13, 15, 16, 17, 18, just look at those and just make sure that they're doing stuff. So here we go. We're going to start on pin 10, which is ROM H. Now, ROM H and L go to the cartridge slot. This is for cartridges. So nothing's going to be on there. Right? There's no cartridge even plugged in. So that's fine. But if it were stuck low, that would be a problem. I mean, with no cartridge installed, it wouldn't be a problem. But if you put one in there, it would be a problem because it needs to deselect those lines. So 10, 11 look okay. Next one is IO. Looks fine as well. If we power cycle the computer, let's see if we see any activity. Not really. It's just sort of low. Now we're on pin 13, which is the GRW pin, which I think goes to the VIC chip. It's like graphics read write or something like that. Oh, no, color RAM. Okay, that goes to the color RAM. It's funny, we're not seeing any activity. We're not seeing a bus conflict because it's just high all the time. But that could be because the system is not even executing code, like it's stuck. And because it's not running anything, it's not, you know, nothing is talking to any of the peripherals. But the thing is, we're looking for lows. We're not, highs are, they're one problem, but it's the stuck lows that are the issue. So that was 13. Pin 15, which is over here. Is the computer running? Yeah, it is. Well, that's a problem. Yeah, that's a hard short to ground. Hard short to ground. So that's the character ROM, and that means the character ROM is going to be selected all the time. And when I turn the computer on, there's like nothing. Absolutely nothing. If we go to the kernel ROM next, that's normal. That's the kernel ROM trying to be selected. Then we have basic. That's pin 17. That's fine. And the last one here is CAS RAM. So this is like normal RAM activity. So our problem right away is this. This is pin 15. That right there is a big problem. Now we have two approaches for troubleshooting this particular one. So we know that it was the pin 15 on this, which is the character ROM line, and that's the character ROM. Both of these are in sockets, so it's quite easy for us to troubleshoot. If you have the character ROM in a socket, but the PLA is soldered, for instance, then what you can do in this case, and that's because just that one line looks like it's stuck, is we could take this chip out, so it's out of the board altogether. That means that even though that select line is bad, well, there's no chip in there to try to like create a bus conflict, maybe the system will work the rest of the way. Without a character ROM, you're obviously not going to really have a functional system, at least in basic, but it should give us like blue borders and stuff like that, maybe some garbage on screen. So let's give that a try. So no cartridges in the machine right now. Yeah, okay. So we're getting like blue border, we're getting there. I mean, the fact it's all garbage is because there's no character ROM installed, but the system does appear to be working. What we can do now is put in the dead test ROM, because the dead test actually doesn't use the character ROM at all. It uses its own internal character ROM basically. And let's see if this works. I have a feeling this is going to be it. Now, I don't think there's anything wrong with this character ROM, although there could be, because it could be shorted internally. Oh, there we go. Yeah. So it could be shorted internally and pulling that line down to ground all the time. But now that it's removed from the board, that's really easy for us to see, because all we need to do is just use the oscilloscope probe here and just look at pin 15 now and see if it's working. Okay, so anyways, we'll get back to diagnostics in a second. Obviously, this computer is working a lot better now. So with the computer powered up, let's go to pin 15. Yep, absolutely stuck to ground. Like that's one of the other lines. That's 16, which is, which one? Kernel, looks normal, but 15, dead. Absolutely dead. So that tells us there's nothing wrong with this chip here. Well, most likely nothing wrong with the chip, and that it is the PLA. So let's pop this out and I'll find a replacement to test with. Okay, I have this one that came out of the that other board that I stole the character ROM out to fix the previous computer. Let's get this in there. Maybe I should do it in a way that doesn't bend the pins though. There we go. There we go. All right, we can pop the character ROM just in. Okay, that is in. Now let's give it a try. No diagnostic cartridges in. It's just direct with everything. Yes, yes, it freaking works. That was it. A bad freaking PLA. Let's take a look at that pin 15 now. There it is. Lots and lots of activity, and that's how it should look. And that's because the character ROM is being accessed by the VIC chip, you know, to draw characters on screen, but it's not doing it all the time. It's just doing it when the VIC chip is busy talking to it so it can generate the characters. And if you're, for instance, going to have a software-defined character set on the Commodore 64, it would deselect the character ROM, and then it would start reading from RAM for that same kind of information. I think it's like a 2K ROM or something like that. So anyways, yeah, sweet. Bad PLA. So it was a red herring and we had those MOS chips on there. They're all fine. It's this chip that actually died, which honestly is par for the course with these computers. All right, the diagnostic harness is all reconnected. And we'll power this thing up and let's hope it's fully functional. Right off the bat, we're getting a good screen. It's clear. It doesn't look anything wrong. We're hooked up over composite just like we were before. So therefore it's not going to be the sharpest text, although pretty good. I don't see a lot of jail bars or any other issues. Let's make sure that the speakers are turned up. There we have it. It's running the sound test. Everything is passing. That's freaking great. And let's do an 8-bit dance party real quick, just so I can make sure the SID is absolutely fully functional. Ooh. So it works. Doesn't quite sound right though. It's pretty good, but I'm gonna say there's some filter problems on this SID, just a few. I'm just going to play a couple SIDs in the SID player here just to see if I can hear any other little issues with the SID. Yeah, this sounds totally wrong. No, something's wrong here. This is not right. So I'm gonna grab the other machine, the one that we just fixed before this one, and I'm gonna play that same tune, and I think we'll hear that it sounds quite a bit different. All right, we were playing Cybernoid 2. Yeah, okay, so like the background notes are just louder on this one. You can hear them much more clearly. Doesn't seem actually like, it's not as bad. It's not like the SID is broken on the other one. It just, the filters sound a little weird. So some of the filters make it quieter than it should be. And I think that's the main issue. Let's let this get into the main part of the song here in a second. Yeah, so this sounds exactly like I would imagine it should sound on this one. Really, really good. I'm gonna switch back to the other one. Yeah, okay, so back on the other one. You can barely hear the notes, the like brrr notes in the background. All you hear is the main like brrr, and that's it on this one. So that's the issue with this one. Let's let it get to the main part of the song. Yeah, again, it's like some of the notes are way too loud and other ones you can just barely hear them on this one. Oh, this one, I know this track. This sounds fine. So that's the problem with these SIDs when they go bad. It's like, it might be only certain filters that aren't working properly, and different tunes will use different filters. So some games are gonna sound totally normal and other ones not. So if you buy a SID online and you hear like even a sound sample, you need to hear like a whole bunch of different sound samples to make sure that it's working in all circumstances. Actually, this doesn't quite sound right either. I don't know. It's hard to know because every SID sounds a little bit different. But let's see here about this one. Oh yeah, no, something's wrong with this one too. There's like notes we're not even hearing at all right now. Enough of that. That's it. That's the SID for you. It's just it's an analog device. It's a digital device, but it's also an analog device. It does both. And parts of the chip can get damaged, or just from age. Like, I don't think, someone actually did anything to the chip that damaged it. But point being is that this chip is not operating even as good as a normal SID should work. Therefore, I'd give this like a marginal functionality rating. So you could get by. If you didn't know any better, it'd be fine. But like that last song there, Syncopated, it just sounded completely wrong. It was missing all sorts of like the nuance and the notes and stuff that should be there. They're just not there. And I bet you with the regular diagnostic ROM, the little notes it plays, probably sounds totally fine with that because it doesn't apply any filters. The filters are really applied by the musicians that code for the SID, and they push the chip to the absolute limit. And unfortunately, that reveals some of the little shortcomings of certain of these chips. And I think I'm just gonna draw an M on this just to indicate that it is a marginal part. So yeah, that's the unfortunate truth. Luckily these days we have good replacements for SIDs that are not gonna fail in time like these ones will. So yeah, if someone was gonna use this machine again, they just need to probably replace that SID with something a little bit better than this one. So the machine with the warranty void sticker, even though this thing had been serviced before, is back in operation. And there's my little label. Fixed, bad PLA, and it has a marginal SID. But otherwise, yep, the black screen and the white line was actually just this bad PLA right here. Let me just draw an X on it. Yet another bad PLA. So many of these in the dead parts bin. Look at that, 2 chips, all right. So I think I'm gonna end this video here. I thought both of these were gonna be super simple and boring fixes, but you know what? I think the troubleshooting process I went through on both of these is still pretty useful because with an oscilloscope, I was able to see the faults on both of these machines to zero in on exactly which chip was wrong or bad. And I didn't need to actually go ahead and desolder a bunch of chips that weren't the problem. And yeah, that's the benefit of using good troubleshooting steps and an oscilloscope to see the problem. It's all about seeing the problem so that you don't go taking chips off boards that you don't need to. Every time you desolder a chip from a board, you do risk damaging the board, and then you've created another problem that didn't exist, which can make your troubleshooting so much more difficult. If you like this video, I'd appreciate a thumbs up. I obviously have a lot more Commodore 64s to fix. Well, there's at least 6 more over there that are broken. So if you want to see more 64 repair videos, let me know, put a comment down below. I know people do like these, but I think there's another subset of people that watch my channel who go like, oh, not another 64 repair, and they roll their eyes. Thing is about these machines is they do break a lot, well, at least the bread bins. And I think the troubleshooting techniques that I show when I fix these, I think is really useful and can be applied to any type of machine. So even if you're not a fan of the 64s and you're never gonna fix one of these, still the techniques I'm using could apply to fixing any other kind of old retro computer like this. So yeah, thumbs up if you liked it, thumbs down if you didn't. Comment down below, all the usual YouTube junk. Subscribe if you haven't already, and huge thanks to my patrons. Their names are scrolling up, no, this side of the screen over here, I think, this time. They make it possible I do this full time. So if you want to become a supporter of the channel, there's a link in the description below. And really, I just can't say thank you enough to my patrons. And I guess that's gonna be that. So stay healthy, stay safe, and I will see you next time. Bye-bye.